Hello class and welcome back. Today we're diving into the core of what we do as mechanics, understanding the vehicles we work on. Our video lesson today will cover the typology of motor vehicles and the characteristics of vehicle systems and components. We'll be using plenty of technical English terms so you can feel confident and professional in the workshop. Alright class, let's start with the basics. How do we classify the vehicles we see every day? This is the typology of motor vehicles. The most common classification is based on the vehicle's body style and intended use. First, we have the passenger vehicles. These are designed to transport people. We're talking about your typical sedans, which have 4 doors and a separate trunk. Then there are hatchbacks with a rear door that swings up, providing access to a combined passenger and cargo area. For larger families or those needing more space, we have station wagons and minivans. Station wagons are like extended sedans with a roofline that continues to the rear, while minivans are larger, boxy vehicles with sliding doors, great for carrying multiple passengers. Moving on to a very popular category, SUVs, or sport utility vehicles. These are built on a light truck chassis, offering higher ground clearance and often all-wheel drive or four-wheel drive capability. They come in various sizes, from compact SUVs to large full-size models. Then we have light commercial vehicles, or LCVs. This category includes pickup trucks with their open cargo bed and vans, used for transporting goods or people. For heavy-duty applications, we have heavy commercial vehicles, or HCVs. This is where you find semi-trucks or tractor-trailers, which are essential for long-haul freight transport. Finally, we have motorcycles and specialized vehicles like buses and construction equipment. Each of these has unique mechanical characteristics that we need to understand. Now that we've classified the vehicles, let's look at what's inside them. A vehicle is a complex machine made up of several interconnected systems. Let's break down the major ones. First and most famously, we have the powertrain. This is the heart of the vehicle, responsible for generating and delivering power to the wheels. The main components here are the engine, the transmission, the drive shaft, and the axles. The engine is where the magic happens. We're talking about the cylinder block, the pistons, the crankshaft, the camshaft, and the cylinder head. This is where combustion takes place, converting fuel into mechanical energy. The transmission then manages the power from the engine, using a series of gears to adjust the speed and torque. Next up is the chassis and suspension system. The chassis is the vehicle's frame, providing structural support. The suspension system, which includes shock absorbers, struts, and control arms, allows the wheels to move up and down independently, ensuring a smooth ride and maintaining traction. A crucial safety system is the braking system. This system uses hydraulic pressure to slow or stop the vehicle. The main components are the brake pedal, the master cylinder, the brake lines, and at each wheel, the calipers, rotors, and brake pads. On older vehicles, you might find drum brakes. We also have the electrical system. This is a vast and complex network that powers everything from the ignition system to the headlights and the infotainment system. Key components include the battery, the alternator, which recharges the battery, the starter motor, and the intricate wiring harnesses and fuses. Let's not forget the cooling system, which prevents the engine from overheating. This system consists of the radiator, the water pump, the thermostat, and the coolant hoses. It circulates a mixture of coolant and water to dissipate heat. Finally, we have the steering system, which allows the driver to control the direction of the vehicle. This system typically includes the steering wheel, the steering column, and the steering rack or steering box. Many modern vehicles also have power steering to make turning easier. So, to recap, we've covered the different typologies of vehicles, from sedans to semi-trucks, and we've identified the main systems and their key components. Remember these terms: powertrain, chassis, suspension, braking system, electrical system, cooling system, and steering system. This is the foundational knowledge you need. In our next practical class, we'll be getting our hands dirty and identifying these components on real vehicles. See you then. Hello class and welcome back. Today, we're going to demystify one of the most vital and often misunderstood aspects of modern vehicles: the automotive electrical and electronic systems. We'll cover their operation and characteristics, as well as the fundamentals of automotive electricity and electronics. Get ready to learn the technical English terms that will make you proficient in diagnosing and repairing these crucial systems. Alright mechanics, let's power up our knowledge. Every component in a modern vehicle, from the ignition to the infotainment, relies on the electrical system. Understanding its fundamentals is absolutely essential. At its core, automotive electricity is about the flow of electrons. We measure this flow in a few key ways. First, we have voltage, often referred to as electrical potential or electromotive force, EMF, measured in volts. V. Think of it as the pressure that pushes the electrons. Then we have current, which is the actual flow rate of these electrons, measured in amperes, A, or simply amps. And finally, resistance, measured in ohms, omega, which is the opposition to the flow of current. Every wire, every component has some degree of resistance. These three concepts are interconnected by Ohm's law, which states that voltage equals sign, current x resistance, VI/R. This is a foundational principle for troubleshooting any electrical circuit. Our primary source of electrical energy in a vehicle is the 12-volt, 12V lead-acid battery. It provides the initial burst of current for the starter motor and acts as a reservoir for the electrical system. Once the engine is running, the alternator takes over, generating alternating current, AC, which is then rectified to direct current, DC, to recharge the battery and power all the vehicle's accessories. Now, let's look at the individual players in this electrical symphony. Every electrical system is made up of circuits. A basic circuit requires a power source, like our battery, a conductor, the wiring, a load, the component that uses the electricity, like a headlight bulb or an electric motor, and a ground connection to complete the circuit. Fuses are critical safety devices. They are designed to melt and break the circuit if the current flow exceeds a safe limit, protecting more expensive components from damage. Always check the appropriate amperage rating when replacing a fuse. Relays are electromechanical switches. They use a small amount of current to control a much larger current flow. For example, your horn or headlights might be controlled by a relay, allowing the dashboard switch to operate at a lower current. Switches open or close circuits. We have various types: toggle switches, push-button switches, and more complex rotary switches for your lighting or climate control. The wiring harness is the nervous system of the vehicle, containing bundles of color-coded wires, each with a specific purpose, carrying power and signals throughout the vehicle. Proper wire gauge is crucial to prevent overheating and voltage drop. While electricity handles the raw power, electronics manage the intelligence. Modern vehicles are essentially computers on wheels, controlled by a network of electronic control units, ECUs, also known as modules. The most prominent ECU is the Engine Control Module, ECM, or Powertrain Control Module, PCM. This brain monitors various sensors throughout the engine, like the oxygen sensor, crankshaft position sensor, camshaft position sensor, and mass airflow sensor, to precisely control fuel injection, ignition timing, and emissions. Other vital ECUs include the Transmission Control Module, TCM, the Anti-Lock Braking System, ABS Module, the Airbag Control Unit, ACU, and various body control modules, BCMs, that handle things like power windows and central locking. These modules communicate with each other over high-speed data buses, such as the Controller Area Network, CAN bus. This allows for complex inter-module communication and system integration. When there's a fault in an electronic system, these modules often store a diagnostic trouble code, DTC. We use an OBD2 scanner, that's Onboard Diagnostics Generation 2, to retrieve these codes. This is our first step in diagnosing electronic issues. The scanner plugs into the Diagnostic Link Connector, DLC, usually located under the dashboard. Understanding the data stream from these sensors and modules and interpreting wiring diagrams and schematics are critical skills for any modern automotive technician. You'll often be looking for sensor readings that are out of specification or communication faults between modules. So how does this translate to practical work? When you're troubleshooting an electrical problem, always start with the basics. Visual inspection. Look for loose connections, corroded terminals, or burnt wires. Check the battery terminals for corrosion and ensure they are tight. Voltage drop test. This is crucial. Instead of just checking for 12V at a component, check for voltage drop across a circuit. Significant drop indicates excessive resistance, often due to a poor connection or damaged wire. Continuity test. Use a multimeter to check if a wire has a complete path for current to flow, ensuring there are no opens in the circuit. Resistance check. Measure the resistance of components like sensors or heating elements to ensure they are within specification. Ground integrity. A poor ground connection is a common cause of electrical problems. Always verify the integrity of ground points. Remember, safety first. Always disconnect the negative battery terminal before working on electrical components to prevent accidental short circuits or damage. In summary, we've laid the groundwork for understanding automotive electrical and electronic systems. We've covered the fundamentals of voltage, current, and resistance, the roles of key components like fuses, relays, and switches, and the intelligence provided by ECUs and sensors. Mastering these concepts and the associated technical vocabulary will give you a significant advantage in diagnosing and repairing modern vehicles. In our practical class, we'll be getting our hands dirty and identifying these components on real vehicles. See you then! Video fades to black with a title card. Mechanics class, next up, practical application.